For this scenario, different cylindrical pipes are rolling down an inclined plane, and they're asking if there's multiple types of pipes with different mass, radius, and length, would they all arrive at the same time? And the answer is yes. So we figured that out by using two different equations, the force equation and the torque equation. The force equation is tension minus mass times gravity equals negative mass times acceleration, since it's going down, so it's negative. And the torque equation, which is torque equals inertia times alpha. And you know that torque is the radius times the force, and since it's an inclined plane, you have to add the angle, which is sine theta. That's equal to inertia times alpha. When you have to have t on one side and everything else on the other side. So when you have t, you have to plug this t back into the first equation, which is the force equation. So when you do that, you get this equation, which is inertia times acceleration over radius squared minus mg equals negative ma. And then you have to have acceleration on one side and everything else on the other side. So when you plug in, a in the end is equal to g over 2 times sine theta. So because of this, whether there's different radius or length or mass, it doesn't matter, because the radius, mass, or length doesn't show up in the final equation after you cancel out other components. So yes, they all arrive at the same time. The second one asks, does it matter if you replace m or r, which is mass or radius, with different values? The answer is no, because when you use conservation of energy, you start with mass times gravity times height equals half mv squared plus half iw squared. We plug in for inertia, and that's mr squared, and the w is v squared over r squared. Well, it's v over r, but remember it's squared, so everything has to be squared. That's tricky, so you have to remember that. And when you cancel out everything and have v on one side and everything else on the other, is v equals the square root of g times h. So that means that it doesn't matter if you have different mass or radius, because there's no mass or radius in the final value anyways. So there you go.